This video is about making my robot development life a little bit easier. I've been working with ROS recently, the robot operating system, and recently I built this, which is a two-part series, one for the hardware design and the second part for getting ROS mapping and the navigation stack up and running so it can autonomously map and navigate its environment using the laser scanner and the wheel odometry, and that works pretty well. So far though, I'm running RVIZ, the ROS visualizer, and also the navigation stack itself on my laptop, so I can go around the house and try it in different areas. However, this is a Windows 10 laptop, so I'm using VMware to run Ubuntu 18.04 and run ROS on there. Now this laptop's only got 8 gig of RAM, so the VM's only got 4 gig of RAM, which isn't really enough, and ROS doesn't run that well under VMware anyway. There's a number of issues with RVIZ showing the laser scan graphics properly. Basically you can't change them to a colour you want, so you end up with really small dots and it's hard to see, and that's something to do with the graphic rendering within VMware on virtual hardware. So I could of course dual boot this laptop or boot it off an external disk or something like that, but I'd actually really like to build a sort of transportable PC that I can attach things to and use it as kind of a utility workstation for robotic development. Now, I've just upgraded my main PC that I do all the production for these videos on and all my CAD, and I did that with Geekawatt, and you can check out that video in my channel, went out a couple of weeks ago, and that's left me with my old PC, which is kind of okay spec. It's an i5 from about 4 years ago, but it's still perfectly functional. So today we're going to transform that into something to use for ROS development. So let's have a look at the old PC. Yes, I'm painting the room white at the moment and the intro was done at the end, so sorry for the poor continuity during this video. Here it is. Yep, the feet have snapped off, so it's a bit wobbly, it doesn't sit straight anymore. It's not too bad, I bought it in about 2016, but let's have a look at what's inside. Right, here it is. So the main board is a Z170K from Asus, which was alright at the time. It's got PCIe slots and stuff. It's got a quad-core Intel i5 on it from about 4 years ago with a massive cooler, and also a modular power supply, or semi-modular at least, from Corsair, the 550M. I've already pulled some of the cables out, and I've already pulled out the graphics card. So the original card I had was this one, which is a GeForce GTX 750 Ti, and then upgraded later on when I got into VR to the GTX 1060, and both of those cards are okay. But for now, we've got actually onboard video, and we've also got the option to take one of those M.2 SSDs, which will fit on the motherboard. Although I actually had a 100 gig Samsung Evo in there and another 2 terabyte actual disk with spinning metal. Here's the main board, and this is the cooler that's on it, which is absolutely ginormous and completely impractical. What we really want to do is make this as low profile as possible so that we can get a screen in and we don't have a massive box to carry around. So I'm going to swap the cooler for one of these, which is one of those water-cooled things with a radiator and a heat pump that takes the heat away. And that looks like this. So we've got this copper plate and a little thing with a pump that goes on the CPU, so that's much smaller, and then we've got these heat pipes of liquid and basically a radiator and a fan which go on there, so we can take that some distance away and keep very low profile where the board is. So we've got the original 120 gig, in fact, Samsung Evo solid state drive that's been good for me for about 4 years to boot the operating system off. But actually, to even make this thing smaller and not have loads of cables, I've got this, which is an SSD. It's one of the NVMe drives that goes straight on the motherboard. This one's made by Asino. It's 256 gig and it was only about £30 on Amazon. No idea if it's going to work well, but we're going to try that first. Yep, there it is, fitted on the board, so I guess we should really power this motherboard up now and see if we can install an operating system on it before we go any further. So we've got the power supply connected to the ATX connector and the additional CPU cables. I forgot to mention I've actually got 16 gig of RAM in here, so that's going to be fine as well. And we've got Ubuntu installing just fine on that NVMe drive. That installed really quick on that drive, so hopefully that's going to be really good, and we can see Ubuntu's up and running fine, so everything's looking pretty good. So now it's time to make the custom case, and we're going to build this monitor into it. What I've made here are some corner brackets and some T-pieces and a piece to hold the motherboard, and I really like the idea of building an open frame PC where I can put things wherever I want. So all of those parts are going to be attached together with 2020 extrusion, and I'll assemble that in a minute. But first of all, thanks to 3D Fuel for sending the filament for this project and a bunch of other projects in my channel. So check out my channel for more 3D printed projects and check out 3dfuel.com. So as you can see, we've got a pretty basic frame here made of aluminium extrusion. Let's just turn that round again. So that's the plate the motherboard's mounted on, and of course we can run the cables up the back like a normal PC. But we've got lots of extra space in here to mount lots of other things that we want that we might need for robotics development. Specifically on this side, which is where of course all the ports are on the motherboard, we've got quite a lot of space here, so we can mount all sorts of stuff. We could have a network switch in here, a USB hub, a big Wi-Fi antenna, or anything else that we want to fit in there that would attach to the ports. Yep, my radiator's on the top here, so we've got the fan actually on the outside, but we've got the cooler here and those heat pipes, so that's nice and out of the way. So there's my fan and the plate that we've made there, and of course we can custom make anything to attach to this frame anywhere. And I use this 2020 extrusion. It comes in other sizes as well, like double the width or triple the width, so a 2060, and that fits together with drop-in T-nuts, which look like this, which are a little hammer-shaped thing, and that's a nut that's on that bolt. So we can basically screw into there, and then that thing turns around and that grabs nice and tight, and we can do it up tight, and we can also move them anywhere that we want to adjust any of the features. I fitted the original power supply back in here. That is sat on a block on the bottom to hold it secure, and on the top it's screwed on with the normal power supply screws, and that of course is bolted onto the 2020 extrusion around here. So that should be pretty secure. I've made custom clips to hold the ATX cable, and it's really useful just being able to freeform anything and bolt it on this extrusion to make any part you want to. We've also got the other power cables for the CPU as well as a serial ATA cable. That's actually got an adapter on one of the serial ATA connectors that's an adapter to go to the fan. So that's where the AIO pump is plugged in for that big cooler. Yep, I decided we'd put one of the GPUs in, so we've got the 750 Ti there, and I put it on this bracket here with a PCIe riser cable, so that's going to bolt in, and I'll show you in a moment. Basically, this GPU has much better ports than the onboard graphics, so it seemed like a good idea, being as there's tons of space. Alright, so there it is mounted in, and it's bolted on this edge to the 2020, and the ports are accessible here with the rest, of course, of the motherboard there. So I think that's going to be alright. And for anyone else concerned, my NVMe drive I've remounted with a little standoff so it's not at a funny angle anymore. Yep, it's time to power it up and see if it all works now I've put it in the box. Now I've got a wireless keyboard, so all we've actually got is a DisplayPort cable and power, and that's it. Yep, that's the power switch. And also put a red only fan in here, and I put a fan grill on so you can't stick your fingers in. Good, it boots fine. So now it's time to put this screen in here. So the normal stand just plugs in when you get it anyway, so that just comes off, and then I've made these corners which are going to bolt on the 2020, and those fit on here. There's just one I need to remodel because there's a funny panel that isn't on the other corners. Right, the screen's in, as well as some other accessories I've fitted, but before we look at that, it's time for a quick ad from the video sponsor. This brand just wants you to go and have some fun. .tech Domains are sponsoring this video, and they've got some puzzles for technically minded people like you to solve. And if you can solve them, you get the chance to win some amazing prizes. Now, a .tech domain is the first choice for innovative tech startups, as well as lots of existing organisations. CES, the Consumer Electronics Show, have changed their domain to ces.tech, and I've already changed my blog from xrobots.co.uk to xrobots.tech, and you can check it out right now. Every other brand's trying to get you to buy a product or sign up for some offer, but .tech Domains wants you to win some things you actually need. Go to breakthecode.tech to enter now, and I'll put that link in the description to this video as well. The game is time-based, so make sure you go and enter soon. That's breakthecode.tech. Check it out now to win some amazing prizes. Right, now it's time to see what we can get out of my new robotics workstation. My monitor's fitted with those brackets that I mentioned, but what you'll notice is that it's completely upright and it's perpendicular to the desk. And this isn't a very good viewing angle when you're sitting at the desk looking onto it. Really, it wants to be leaned back slightly so that it points up directly at your face. So I've made this magic block which is attached on with a bit of bungee cord, and that allows it to be pulled out and brought around to the other square side and put back down again. And that gives us a much better viewing angle for sitting and operating the computer. Around the front, on the left-hand bottom side of the monitor, I've implemented the USB 3 front ports, and those are plugged into the extra port on the motherboard. And I just took this from a 3.5-inch drive mountable USB front panel and just made a bracket so it can be attached to the 2020, and this can be moved anywhere pretty much on the PC. During the build, I noted that I'd fitted the power supply like this with the fan facing outwards and the mains cable on the top. And that's so that I've got a place to stow the mains cable away, and that's attached with a bracket and 2 Velcro straps that mean it's all contained in there and we can fold it out. Now this is a Y-splitter mains cable, that's the Y-splitter, so one goes into the power supply and one goes into the monitor. Then we just have a single mains cable to deal with to power the whole thing. Now my monitor is HDMI, but I've plugged into the DisplayPort with a DisplayPort to HDMI adapter and then this right angle cable which is the HDMI to HDMI cable. I couldn't find a short enough one that's DisplayPort to HDMI. Now I could have plugged into the HDMI port with a short HDMI to HDMI cable, but actually I want to keep that for a second monitor, and that's because the DisplayPort is the primary one on this card, which means if you have 2 monitors, the login box for Ubuntu comes up on the one connected to DisplayPort, and I can't seem to change that. So if you leave it configured for 2 monitors but you don't plug the second one in, then you can't log in. Also in here I've got a USB hub with the Wi-Fi aerial plugged in, which is just a USB Wi-Fi dongle, and I've also got my wireless keyboard adapter. Now there's a lot more space in this side, so we could actually put in a network switch or a wireless access point to control robots when events start up again. There's also plenty of space in here to stow away my wireless keyboard, although I haven't made a bracket for it. It'd easily fit in there for transport, and a number of other accessories could be fitted as well. So it does weigh quite a bit, but I can happily carry that in one hand, and of course everything's enclosed, so we can just plug in one mains cable, get the wireless keyboard out, and then we can get going. Of course this can also be stored and transported on one side as well, because all the sides are flat, and it runs much quicker than that VM does on my laptop, especially with the operating system booting off that NVMe drive. But will it make the robot work any better? I'm just going to drive the robot backwards and forwards a couple of times. We can see the map there that I've already made, and we're setting a 2D nav goal to go over to the other side of the room. But on the whole, RVIZ seems a lot more responsive, it loads a lot quicker, and it's just a lot nicer using the operating system booting off that NVMe drive as opposed to off VMware. My laptop actually had a physical spinning disk in as well, so that wouldn't have helped the performance either, as well as the shortage of RAM. We've now got 16 gig instead of 4 virtual gigs. So it seems to be running okay, but now let's try putting a new obstacle in the way and let it automatically mark it onto the map. So last time we did have an issue where we put a new obstacle there, and then as the map updated, it didn't quite happen quick enough and the robot spun around a couple of times trying to find its position. But now it seems quite pragmatic and it passes that obstacle with no problems. Let's move that furniture again and make a narrow corridor for it to go through. It handled doorways okay before, but with this test that's where it went wrong and it spun round trying to find its position. And I think that's because I was still on the map, having walked away, and we had about a 3-second map update. But that seems to work okay, and it locates itself just about okay too. So let's move that back again and try another test. So it does proceed cautiously and repositions a couple of times, but on the whole that works pretty reliably. So a couple of other tests at 3 times speed, but you can see this works pretty repeatably and pretty reliably even when I move that obstacle, and here the map gets updated as soon as it scans it, so I'm pretty happy with how responsive it is overall. Overall, I'm really happy with how this has turned out. It's much better running ROS on actual physical hardware rather than trying to scratch around to find a machine powerful enough to run a VM and then find that it's still quite laggy. And I'm really happy with the structure of this and how I can add extra stuff in, so when events start up again, probably next year now, it may well be making an appearance and controlling part of my robots that I'm demonstrating if you happen to catch me at an event. And probably I will build in a network switch or a Wi-Fi router so I can actually have my own network and probably power it from the serial ATA connector that's spare at the back there, so everything's still powered off one mains cable and that controls everything. Now all the projects I do are open source and I put those on GitHub, so I will put the CAD up for this if anyone wants to build one or adapt it and build anything similar. It'll be a solid model that's really easy to modify, not just STLs, and in fact the ROS robot is there as well with all of that ROS navigation stack and the config, all of the Arduino code and all of the setup, and don't forget to check out those 2 videos. So if you'd like to support me through Patreon or YouTube channel membership, then you can, and those links are in the description to this video. Alright, that's all for now.